Hello, and welcome to today's InDiCo-Global webinar. My name is Alton Mulligan from Etsy, one of the partners in the InDiCo-Global project. InDiCo-Global is a European Union-funded coordination and support action project aimed at developing global cooperation for digital standards and related policies from the European Union. The partners in InDiCo-Global are Etsy, CEN, CENELEC, all three of us are European standardization organizations, Martel Innovate, and Trust IT. One of the features of InDiCo-Global is that we have set aside a budget of 1 million euros to fund small projects in our target regions on the basis of open calls for proposals. You can see on this slide, which we'll make available afterwards, the information on the projects that we have managed to fund to date in the first open call. But today, we're going to hear from one such project, a study on the geopolitics of semiconductor standards and HPC chips, navigating China's influence on global technology norms. In this session, Dr. Susann Lüdtke will present early findings from her research, mapping China's evolving semiconductor and HPC standards ecosystem. But first, we're also pleased to be joined by Uwe Rüddenklau of Infineon, who will bring an industry lens to this critical conversation. Before I hand over to Uwe, I'd like to remind you of some quick points about our webinar today. Firstly, as you may have heard, the session is being recorded and will be shared on all InDiCo-Global channels. Please keep your microphone muted unless you're speaking to avoid background noise. Please use the raise hand feature if you'd like to contribute or ask a question during the discussion, but we'd prefer to keep the questions towards the end of the session. Please feel free to share your comments or questions in the chat box as well. And if you are speaking, please do try to turn on your camera if you're comfortable. It's not just that it's always nice to see who you're speaking with, but if people are joining this session with some difficulties hearing, then seeing lips move is much more easy for them. Now, sorry, this to show you the quickly agenda. So now over to you, Uwe.
Yeah, thank you very much. I will now share my content. My name, as I said, is Uwe Rüddenklau. I'm with the company Infineon Technologies, and I'm leading there the global standardization, means looking into standardization worldwide, whatever it's going on. And there's a lot currently going on semiconductors. Therefore, I talk here about the importance of global standardization and give some relationship, what's ongoing in Europe on standardization and there the efforts. Just a glimpse. In general, for us as semiconductor company, standardization in geopolitics is important, and it's getting even more important these days. And we see standards very important for many areas, because they can enable, as we said here, global cooperation and economic growth. For sure, as an industry-driven company, you have to look into this area as well. And I will give also some information into this now at the beginning. Yeah, what's going on? As I said, we used here the picture. I used here the picture of a kind of water and boat. So we are navigating here standardization in industry. What is there relevant in standardization? It helps us really to shape market also, and this is an important point in favor of industry business, to see what's going on and where are new areas where we can bring in new ideas into the market. And semiconductors, as you know, are mainly everywhere in the meantime. And for us as an industry, it's important with these standards and standardization work, we can secure also our investments in the technology, manufacturing. Maybe some of you heard about in Europe about CHIPS Act, where manufacturing is one part of it, but also the technology as well as the work behind. So it means the products and applications out of this. And secondly, we use this for sure also if you have standardization work, set in this part, either globally or could be also Europe related. I show this later, to win and make path for business itself. And the equally important part is for sure with this, there comes also some intellectual property, IP, also to protect this in this standardization work in products and systems. With this, I go now into some more details, and for sure I will not read through all the information. You will get the slides also afterwards. What's going on in Europe, and there's a lot of regulation coming also from the European side, European Commission side, which is very relevant for the industry. And I'll show you three parts, more the past, what is already existing, what's recently happened, and what is the latest, so the news. You see here many regulations, and they're all based on the new legislative framework. There's also a link which you can use if you are not aware of what this is all about, but it's a very important one where the work of standards and standardization is relying on and gives you a so-called presumption of conformity. One important one I highlighted here is the Radio Equipment Directive, in short, RED. You will see in the next slide why. Recently, we have many more, and as I said, they're all in place. Depends a little bit on the country. There are still discussions how to implement them. For example, cybersecurity is currently an important part. And here there's a Cybersecurity Act where currently there's also requests to comment further, and if it's good as it is, or if some add-ons have to be done. And currently the main work, and I think this is relevant also globally, as there are discussions usually also happen not just in Europe, also globally, then AI, data, cyber resilience, as I said, or cybersecurity, eco-design. And there were some discussions also on patents, but currently this is not planned to happen. So you see there's a lot of things ongoing, and if you have regulations, standards usually follow. So there are standards development then happening in Europe, but usually, and this is also what we are looking after from our company and the semiconductor industry, to make use of existing standards which are globally available, for example, in ISO, IEC, wherever possible. One example out of this is that in practice, and I make this short, is that this related to the Radio Equipment Directive amended, where industry and others, for sure society, brought parts into the standards which were coming from that law. This was about portable products with USB-C ports, which are in the meantime already available. So you know it maybe from your smartphone. And this will come also to laptops, if not already applicable soon in 26. What is the advantage of this? Yeah, there was from the European Commission also a calculation what kind of savings this will have. So it should have savings set because chargers which were so far necessary are not necessary anymore. Only if the society is asking for this, so could save up to 250 million euro. But even more important, maybe these times also to reduce the e-waste, and this is around about 1,000 tons annually. So it has also an impact on consumer and environment, this laws and related standards to it. And for sure, if I look again also from industry point of view, it has also an impact on the industry with additional business, as I said before, with USB controllers, which you can get onto the market and create new business opportunities. So it has really, standards has really something which is important to society and industry. And one fourth last slide is about international standardization. As I said, for us, it's very important that as much as possible, standards are based on global standardization work. What could be the impact, and made this very brief, what could be the, on one hand, the effects from the governments, the pros and cons. So in case industry invests more in resources to address standards, and more, as you saw, standards are coming, for sure, the pros, you can keep the status quo itself. Worst case, cons could be industry doesn't develop it. On the other hand, if industry would deallocate resources from standards, because always a decision where you bring these people in and the experts, and these are really the experts which you go into the standardization with a long experience. This could have, yeah, on one hand, more control over the industry and the policies. On the other hand, it might require subventions to keep the industry afloat. So there are different aspects on this. And without going into any further details, I have one last slide to summarize this from geopolitical point of view, which you will hear later, specifically related to China, but this is also in general, that standardization is definitely a tool, as I said, for business and countries to establishing new markets, emerging markets, secure investments, and create new opportunities, as you saw there with the example. It has also impact, and is not limited to business environment, also geopolitical implications, depending how standards are used. And countries can use for sure also standards, specifically if they are national, to their interests to influence markets. With the international standards, for sure, you influence also global markets if they take them over, which is always the goal from our view, or to protect domestically your industry. By setting standards in favor of the industry foreign markets and companies for sure working there, and therefore affecting the competition in the global market. And yeah, in certain areas we see this already. But our wish and hope is always to go for global standardization. This I would finish, and thank you very much. I would then hand over to Susann, to you, for the dedicated one, and stop my sharing. Thank you.
Thank you very much, Uwe. My name is Susann Lüdtke. And I'm from Lüdtke Intelligent Analytics. Actually, while I'm, would say, being kind of a unicorn in the field of geotech and strategic risks, especially if it comes to standardization, innovation, analytics, not only for China, but also a major background is on China. I'm pretty much, being for more than 10 years in general in this field, and wrote originally my PhD on technical standards lobbying in China in the field of energy efficient building standards back to 2013. However, so with one of the biggest shots, I would say, I started my own company after also working for a big patent data analytics consultancy over more than 6 years, and just started with Lüdtke Intelligent Analytics this year, and was very happy to get the chance to run this really cool project. Actually, I have run already a project about EV chips together with other EU member state, but happy I see HPC chips, high performance computer chips, are however very different. So it's kind of a totally new project at all. And I'm very happy that InDiCo-Global is then giving me this chance to have the grant under the Horizon Europe. So I want to start with a short introduction to the De-risking China project, how I'm going to do it, what's the main idea, background of the project. I'm doing the research, but want to do this very shortly, briefly, and then give a very short background on high-performance computer chips, and also about resilience scenarios regarding the global semiconductor supply value chain. But most of part of the presentation I want to hold about, would say very early findings about China's innovation potential and standardization potential in the field of high-performance computer chips, and then some expected takeaways. Okay, so let us jump quickly into the general topic, computing, semiconductors, and HPC. There's a famous tale of two cities from Charles Dickens already saying that IT was the best of the times and the worst of the times, and the age of wisdom and the age of foolishness and so on. I do not want to read it out, but you can see already there are some, lot of pros and cons into the entire field of IT. And actually, if we think about IT and general aspects of IT, actually semiconductors are like everywhere. Once a very famous interview representative mentioned it's like the oil of the future. So it will be everywhere, and it is used for the modern digital economy. It relies on electronic integrated circuits, generally known as chips, and they are like, serves millions of devices. So we see it as will take us ages to view actually where so high performance computing chips are actually a specific type of chips. So there are very different types of, and most of the people know them because they are, for example, used in artificial intelligence, but not only there. We think about DeepSeek, ChatGPT, and so on. They are all run on very famous and very advanced node chips, but also like quantum computing, autonomous driving, or other applications where you find embedded HPC, and also data center, research centers, and so on. However, there's not only an entire economic dimension on this topic of HPC chips, but also a general one related to more, like I would call it a political or security dimension, if we think about Taiwan and where most of the chips are generally produced. So what is the De-risking China project about? As I already mentioned, it's happily a one-person project supported by InDiCo-Global under Horizon Europe. And I'm running, my central research question is to explore how far actually China is already in the field of HPC chips. If it comes to government support, policies, a lot of patent data analytics will be in. Also tracking publications on HPC chips and standardization this field, but for sure the bottleneck and the heart of the study will be like what all of these efforts of China means if it comes to national and international HPC chip standardization. Like, all the others are like the groundwork to say how far they are actually to really be able to participate in standardization. And at the end, as you know, it is at the heart of the EU Chips Act that the EU should have also a kind of technology sovereignty. This also includes certain kind of economic security, but also for sure something like what we call knowledge security, also to make sure who is leapfrogging us and what can we do also to prevent these things perhaps in certain instances. So all of these things are very important. So as I'm examining this international tech race, I'm also trying to put a little bit more ground, I would say, on the entire debate on so-called China-specific high-tech standards, and are they really deviating from other standards? And this I also trying to have a look in the study, but in the meantime, currently we are still having a look for really matching standards that we can really compare. So we need to see what kind we can really compare here. However, we have already a lot of results if it comes to the potential of China, and I will also dig deeper into this topic now. How I'm going to structure the report. Actually, there are two chapters, I would say, about how to setting the stage in general, understanding more about geoeconomics and markets in the field of HPC chips, semiconductor, and what it means for Europe, especially, I would say, framing or seeing Europe a little bit in this kind of bilateral high-tech race between the US and China in this regard. And the second chapter will be about geopolitics and governance in this field, how countries also counteract to this. So yeah, these two chapters are for sure also giving each other some, yeah, I would say suggestions in which direction it might go. I mean, if we look at economics, we have to look at something like, yeah, cost efficiency, what happened in the semiconductor industry in the last 20, 30 years. I mean, there's a reason why something like ATP, assembly testing, packaging, is in specific parts of the world done and not in others, etc. So all of these are like inter-aligning with each other. However, the major part of the report will be, yeah, I call them kind of deep dives. So I will do first deep dive about geotechnology, as I call it, and innovation. That's the third chapter. And the fourth chapter is then directly leading to geotechnology and standards. So actually, based on my and previous research results from Sabrina Weidmann and others, we are usually approaching the ability or the capability that somebody is actually able to become a standard setting from the potential of, from the perspective of innovation. So we track the patent-based situation and other things like R&D efforts, publications, etc. And then saying how able is actually China really to run own national standards if it comes to integrated circuits or HPC chips in general. And where do we see signs that they are going in the international sphere, or are they doing both, or are they even preferring a third way, or yeah, a three-pronged strategy or something like this? And then at the end, I'm currently very much planning a kind of, yeah, synopsis on a very critical case. I have the company already fixed, but I'm not going to say it here yet. So it is yeah, Chinese big tech giant, I can say so much. And yeah, it is a company where it seems to be that we can see that they actually try to go into the really entire semiconductor supply chain in almost each stage by gaining a lot of knowledge. So seems to be currently something like, yeah, the biggest shot from the perspective of the Chinese Communist Party, because one of the major goals is to be almost on their own and not so reliant anymore on semiconductors from other countries. I mean, this is really was promulgated, especially if it comes to automotive grade chips, very much in the last years, especially since Corona and entire supply chain problems with chips. But we see this now also, they are also going in other yeah, fields of chips, also HPC to run these things. However, let us jump to the next thing. What is actually HPC chips and semiconductor reliance? What do I mean with this? What's the background on this? And that's also a major part of the report, what I just talked about. It's like geoeconomics and markets in the beginning. So what we can really see is, in general, there is an application scope for semiconductor products is very growing very fast. We have high-end advanced node chips, and they are actually essential for both traditional HPC and embedded HPC. Mostly more common in the mind of most people, I would say, are like supercomputers and data centers and research centers and all. But my report will also focus a lot about embedded HPC environments, because these things are for sure especially important for the European industry and large semiconductor companies of various ways. So what's the difference actually between traditional HPC and embedded HPC? I do not want to put it too technical and yeah, make the people here feel very bored. But there are a lot of differences, and it's really fascinating, actually. Maybe one of the thing that I would really yeah, point out here is whether it's close to a data source or physical process or not. I would say that's one of the most important things. So really computing power at the edge is the thing about embedded HPC, and this is much more difficult to control. If you just think about, for example, embedded HPC solutions and autonomous driving cars, etc. I mean, they are not having a stable ground when they are driving. Yeah, it's different to a data or research center that we have, for example, in Jülich or somewhere else in Germany, or in Spain, or where we have other supercomputer centers. So there are really big differences if it comes to this. However, HPC chips are very useful because they can really allow us to assess a large data set of things, and that is really making them in a very advanced mode. A specific category of HPC chips are also used in quantum computer, for example. Okay, let's come back to geoeconomics and the market situation here. I also do not want to put this here too much into detail, but to put it very short, there are some cost efficiency for the happiness of globalization. And I mean, a lot of these things went very well in the last centuries. Always depending for sure on the perspective, whether this was then always as justified as possible. However, what happens through this cost efficiency is also that HPC chip is usually not done in a linear way, just vertical in one place, but there are different steps somewhere. A lot of design, for example, is often coming from UK or US, if you think on ARM-based stuff, the RISC technology. Actually, the UK brand here, I just put also the Japanese flag here because it's related to ARM, and ARM actually now was taken over a large majority from SoftBank, which is a Japanese company. Fabrication, a lot is done in Taiwan. For sure, some also in the US. I think especially think about Intel, etc. if it comes to HPC chips. And the entire or most of these ATP stage, as I call it, assembly, testing, packaging, is done in other countries as well. So what we see here, we see this diversification for sure brings us various choke points actually. And these choke points make us dependent on others. And the question is always, how, I mean, in the best way, everything is great. And I'm a big fan of it was great and it should stay like this. But on the other hand, we cannot be naive. So we see that certain things are going on and we need to make the EU resilient for this. So this is a major jump into the field of geoeconomics and markets. And a second thing I wanted to point out is more about geopolitics and the market. It's one of the key findings of the second chapter. We see actually that China has various dependencies themselves. And that's also an important insight, because if we want to analyze how geopolitics of semiconductor designs in the field of HPC chips standards affect the EU, we also need to see what China has for kind of problems, I would put it like this, and see what they want to do. And what we see, for example, they have a very severe Achilles heel if it comes to manufacturing and lithography. Actually, in the field of lithography, I already find some insights that they are having some, I would say, creative innovations, workarounds to reach also very good results. They are nowadays scaling up a lot in the field of manufacturing, a lot of new fabs, and put a lot of money in this. For sure, they have serious problems, especially if it comes to advanced node chips. I mean, okay, what is advanced? Yeah, in the field of chips, what was advanced according to Moore's law a few years ago is nowadays not advanced anymore. But what I here mean with advanced node chips, really these things what I need for RE embedded solutions, autonomous driving. So something around 7 nanometer, we would call like this, or below. We are now going to define this at that limit. And they need this a lot. We see they have similar problems if it comes to automotive grade chips, but they are produced on a very different nanometer level. So a lot of these general problems, and that China strives currently for more independence for their own IC chip manufacturing, is similar to what happens in the EV chips field as well. They also have a lot of dependencies if it comes to semiconductor IP core, general know-how for chip design, and also the ADAS software. But also going to go away there. So actually what I already find now is it's not a question of whether, but just a question of when and how fast they're actually trying to leapfrog, or at least have some creative innovations, even if it's not leapfrogging, but maybe it helps them already to reach a certain nanometer that's maybe enough for what they need now for specific companies and their solutions. So we also have, as the EU, for sure, a lot of dependencies. I mean, especially if it comes to design, is something not often, I think, publicly so popular. I was pretty surprised actually when I read about these things, because what is more in our mind is about our manufacturing issues, especially that we know most of the chips coming from Taiwan, etc. But yeah, design is very much ARM-based, which is also specific software. There's a difference between RISC-V and OpenRISC and other things. However, I think that's too deep for this short quick tour. So I will just jump in the general question, and I have not yet an answer to this. So I'm very much looking forward to push the report in specific fields, whether we should maybe have going towards a niche strategy, or like somebody called it very funnily, real man, a need to have fabs thing. So whether you needs to have fabs for everything, is it really what we need, or are we going into have a niche strategy because maybe we have specific semiconductor needs if it comes to the industry and companies that are very special, and maybe not for all of these things we need to have fabs, but maybe for some. So however, as always, maybe some people unfortunately don't like it so much in this word, but it's not black and white. So we will see actually what will be the answer to this at the end. So let's go into the main part of my presentation. I think I'm just running with 14 minutes and have still like 15 minutes left. That's excellent. So I can speak a bit slower. Coming to the risk assessment. So what I did actually, I often like to start from an innovation perspective, because most of my services are actually all around high-tech standards, or high-tech risks in the geotech field. And I always want to know actually if somebody can be a risk for somebody else, how good are they actually with what they have. So what I actually firstly did, as coming from a researcher perspective, often I was checking what are the highest quality research papers published in the field of HPC chips coming from China, based on the H index. There are also other indexes, but I usually like this one the most, as this also takes into account citations. And here we can see that China and the United States actually rank both on 67%. And within the EU, actually Germany and Italy are very much on top, if you would call other non-EU members, but still would call friendly pro-European countries in this direction as well, like United Kingdom or the Switzerland. We are not so weak as we maybe sometimes think, so should maybe also have a look more on what we can do and how good we are. So it's not less what we do in this field of research. The question maybe is another, what of this research we can really pull into scalable products to the market to really make money out of this. So but still it's a large difference between from China and the United States towards actually all others, so more than double. So another thing that I also found very interesting is looking at from the patent-based metrics. I found, at least from a very recent look in April, that more than 188K patents seems to be clustered to HPC, high-performance computer chips, and I mean, for sure here, NVIDIA is like over the top of all of them. That's not a real surprise. And we are here also not only speaking about patents related to the design of them, but also for sure to the manufacturing of HPC chips. So that's why, for example, TSMC, Taiwan Semiconductors, also ranked very high. But also not for me surprising, but because I know it a lot from the EV chips field already. But Huawei is already ranking very high here. And one thing will be also for sure to have a look for other Chinese companies like Shanghai Byron is also ranking high. And there are some others here in the list which are maybe not so well known for all here. So it will be also interesting to see really making a deep dive into this, what kind of patents they really hold. Are they really unique? How good is the patent quality? So actually, here I used PatSnap, and as I coming from the patent data analytics field, there are a lot of things I like about PatSnap, but a lot of things I do not like. So also used an additional research for justifying the first findings, and I will go on further. Just one skip back. I forgot to say something important. So actually what we also saw from this landscaping visualization here is that most of the patents are focused on packaging, an ATP process basically, followed by manufacturing and design. So we see it here in the middle of the landscape that a lot of these patents are in the field of manufacturing, package substrate, and so on and so forth. So what we see is that Chinese firms filed actually really less patents, less than 5 patents at all until 2023 for advanced node chips. So this is really less. So we see there's already still a large technology gap. However, this is just a really first finding, and I need to make some additional research on this as well. Another additional analysis I did to justify this use of the PatSnap analysis and what it really tells me and how much I can trust. I had a look at another source from ITIF. It's a very good research paper I can really recommend for people who are interested in this field. And they have used a tool that I worked with more than 6 years, and that is actually really measuring the patent quality and not just about the patent quantity. And they had a look on the category of semiconductor device manufacturing and checked for Chinese companies. And they find actually that these 4 companies, Beijing Chuangqing Holding, and Woolly Integrated Circuit, SMIC for sure, which is a very famous Chinese manufacturing company, and Huawei hold the strongest, which means the highest quality patents, means they are cited a lot and they are also protected in many different markets. Out of China's top 10 largest patent semiconductor patent holders at all. We see, as always, all tools have their advantages and disadvantages, so it's always good to compare them a little bit and looking for the results and then see what is really the best one. What's the likeliness of standard setting at all? That's an important thing, because when I'm usually coming from this innovation background, I'm usually trying to understand how likely is it that the research entity or the others are actually able to set standards at all. And that's another analytical tool that I use in the report to really understand the risk that China is developing diverging or deviating technical standards. Yeah, and that's just a general concept. I will flip through a little bit for the sake of time. What is China's standards mission? For sure, that's also an important thing in the report. General mission, I think that's not new for people that are interested in China standards, is that a general driver is that third companies make products, second type companies make patents, first type companies make standards. That's the famous saying about this. But if it comes to integrated circuit standards, we see actually they are focusing on these 5 categories. That is not surprising. I mean, these are mostly the categories that are used for the entire, to cope with the entire supply chain at the end. So it makes sense that they focus on all of these standards and not just one of them. Does not mean that they have most of the standards in all of these types at all. So as I mentioned already, I will also try to figure out what is a good way to compare at the end specific Chinese national or industry standards for HPC chips compared to European standards, for example. But this I will do as the next step. What is another finding that is also not, from my perspective, not so surprising, but it's still possible that most of the people have not done this research, don't know it. In general, the IC standard system in China is very much similar to the one in Europe we use, also from the way it is organized and classified. However, what's the most important, to click back for a second to outline it a little bit. The SAC TC599 I would consider as the most important one at the current time, especially because a few years ago they have established via the MIIT and their special electronics department, the National Integrated Circuit Standardization Technological Committee. And this one is actually majorly responsible for all the things. So I'm actually researching a lot what is published by them, what I can have found with them, who work for them, who are willing to talk to me at all, etc. And what is also extremely important from my perspective is the CESI, it's the Chinese Electronics Society. And they're also very important in the field of semiconductor standards in general, but also HPC. What is my main, I would say, conclusion for the report, and then later on I come to a small outlook. If it comes to China's integrated circuit standardization ambitions, there are various risks and implications for the EU. For example, if it comes to the industry, it's extremely difficult to see who actually serves which role. So means, is it really a partner for a European company, or is it already a rival, a specific Chinese counterpart? So I would say this kind of examination and differentiation is pretty fuzzy. So everybody would like to have more information on this. I cannot share it here, but feel free to contact me. It's one of my most difficult work scope. Another thing is, this entire due diligence for sure. I mean, if you think about HPC, there's always a civil-military fusion topic in this dual use. So it is not a classical standardization area, I would say. So I would more compare it to when you're doing research about quantum technology standards in China and quantum communication standards. However, good news for now, but as I said, possible that it does not take very long. At the current time, China is still very reliant on HPC chips from other countries. But it seems to be that there's a strong technological catch-up because, as I mentioned, if it comes to lithography, for example, they already built some creative workarounds to have similar lithography techniques and that they can cover things that they didn't have before. But also in radar and signals. If it comes to standardization, actually, they have a lot of resources here. And for sure, the way or the possibilities to participate for foreign companies is pretty difficult. I mean, they are actually, as I mentioned, it's about dual use often, and it's hard to go deeper into this. So it will be definitely a thing to try to understand whether there are differences to standards that are important for HPC chip industry in the EU. So yeah, how would I sum up this not as easy topic, I have to say, is that at the current time, I would put it very simple. I see a kind of three-pronged strategy that China uses. They build autonomous technology ecosystems, for example, with open innovations, things like OpenWIST, etc., alongside also trying to still participate in international standards, at least in this fora that are really in their own interest. But it seems, and there are clear goals regarding this, like how many standards to be set, etc., also producing own national standards that fit more their own needs within China, especially if it comes to the field to be independent from outside China semiconductor industry fields. So what are my expected takeaways? For this entire report, I see 4 key topics. First is to really get a good sense and taste of the thing about innovation. Where is cooperation possible? Where is competition? Where are risks of technology transfer, leapfrogging, knowledge security? Where are perhaps export restrictions needed? Or where do perhaps export restrictions even make China being more innovative faster? A second thing about standards, for sure, is one of the most important topics here. Where does collaboration or non-collaboration is important? Where to really be careful if it comes to deviating technical standards. So something like a yearly warning system for diverging standards based on data analytics. I'm having some interesting things here in my mind, but it's a bit too broad away for now. For sure, economics and politics, how to avoid to be too resilient on ourselves, and how can we as the European Union support our own industry, also what it means for the defense industry, for example. As far as I know, there are also a lot of standards taken over from the defense industry, from the field of HPC, for example. And then a critical case risk scenario. As I mentioned at the end, I will like to do a synopsis on one specific Chinese tech giant and try to assess specific risks and what it would mean for Europe if things are totally substituted by a consortium of big players, to put it friendly, and what it means for us. You are welcome to ask more questions. I'm done. And that's just a short talk over my services, but that's the most important thing. So yeah, let's try to be before everything else and not wait too long and analyze early.
Well, thank you very much, Susann. This was extremely interesting, and I think I'm sure that we will continue this conversation because you're as you say, you're beginning your research or at the beginning of it, and well, of course, not at the beginning in full, but for this particular project. So, and so at this moment, are there any questions or comments from participants? Because I think we will for sure facilitate this discussion later on in a different form. So what I will then do is I'll try to give a brief recap, but it's very difficult.
May I ask a question?
Yes, of course.
If I'm
yes, of
one
course.
of the
Please,
presenter,
Uwe.
back to Susann. I would have one question, Susann. As the focus is on high performance chips, HPC chips. Currently in Europe, as you said, we are not really developing this from semiconductor point of view. I can speak also for our company and others. So therefore, for sure, this is a very specific area. Is your analysis specifically on this HPC chips or more in general? Because certain things look more general and some specific to HPC.
Yeah, it's a little bit from both, I would say, because a lot of things are comparable actually from, I mean, the general thing like geoeconomics and markets, geopolitics, etc. I mean, you cannot look at this without the other thing somehow. But I'm currently planning to have the final comparison and really have a look at risk and how far China is really from a HPC chips perspective only. That's really my goal.
Okay, thanks.
Thank you. So,
sorry, Rob.
Yes, please,
sorry.
Anita.
There's another question.
In the chat?
Yuncha. No, Yuncha has raised a hand. So
Okey-doke.
please unmute yourself. Yeah, and go ahead.
Yeah, my name is Yoon Chao-hu. I'm affiliated with Huawei Technologies. I have a question related. I think it's very brave to take the topic as high performance computing and put that in the context of geopolitical, let's say, scenario. There is a lot of, let's say, perspectives of national security, let's say, domain in that perspective. I mean, the Europe, US, as well, China are putting those efforts there. So when you talk about standardization related to high performance computing, what are you thinking in that area? What do you think would be useful to be standardized in that area?
Is a question to me or to Uwe as well? Yeah, I mean, I think there's not an easy answer to this. It depends on what are your goals as a company and where are your bottlenecks. So depends on the product. I mean, there are so many different ways, to have HPC chips. Those used in the autonomous driving cars, as far as I know, are not the same used for AI solutions, etc. I think it's nothing you can say on a general level. You need to see what are your needs and what do you exactly need, and then you need to see where it makes sense to join standardization. And for sure, some standardization is more easier and some are perhaps more technological different. I mean, in general, everything related to ATP, assembly testing, packaging step seems to be not as complicated as far as I have saw it from my research compared to design technology for chips or manufacturing, lithography, everything that comes with photonics, etc. But yeah, I think I'm not a HPC engineer in this regard, so it's hard to say.
Yeah, I mean, that's an interesting perspective. In my context, when I'm thinking about HPC, high performance computing, I'm talking about exascale type of, let's say, infrastructure, which is in large, very supercomputing centers, etc. And there I see more the geopolitical arena kicking in because the US approach, the European approach, as well the Chinese approach are quite different in that area.
It's true.
When
Actually,
you talk about automotive, there is a different perspective, and of course you can talk about high performance chips or computing there as well. But then, yeah, that I see more, let's say, affinity with standards needs in that area.
Yeah, it's a difficult thing. I mean, I do not want to write a 500 pages report. So I'm now yet not 100% sure on what kind of standards I'm really focusing at the end. Because on the one hand, for traditional HPC, there are a lot of interesting things going on, but I find them not as interesting because, yeah, I mean, the supercomputers, yeah, okay, it's interesting. But I find it more interesting actually what is more needed from a industry perspective and what are really embedded HPC solutions. So I tend to be more looking on this embedded HPC perspective at the end. And for here, I can say it's not easy to say what to join. It's an additional research, I would say.
Okay, thank you.
Thank you. Thank you, Yunchao, for asking this. Maybe Ultan or Uwe, you would like to respond briefly to this?
Yeah,
Yunchao's
maybe
question?
I can. By the way, hi, Jun. As you know us, it's a very good question. I was also thinking about it because certain areas, from my view, a semiconductor company, I would say, it doesn't make sense to standardize this, and it's a different topic, as you said. If you're talking about semiconductor nodes, which are required, these are usually not standardized. What is standardized then is usually the testing areas of it, how to test it. This could be, for example, one area. Thank you.
Thank you. And I would sort of briefly like to conclude. And first thing I would then say is that any presentation starting with Charles Dickens cannot be a bad presentation. And so this indeed, this Tale of Two Cities is very, very interesting because it's also been used in the context of smart cities, where you can have this tale of two cities, a cities of control or a cities of let's say more solidarity or more empowerment, sort of. And sort of this is the so this also thing comes back to your best of times and the worst of times. And I think if we look at China in that respect, sort of a lot, I think looking at, for example, IoT, Wen Jiabo in 2009, 2010, already said that IoT was wisdom of the earth. And at that moment in time, in 2010, 9 out of the 12 top politicians were engineers or scientists. So it's been a very long, and even before, of course, it's been a very long kind of philosophical understanding also of the ontological change that we see with these technologies. It's not just analog plus; it becomes a hybrid situation. And so I think a lot of what you said and a lot of the assessments can also be seen as actually quite neutral in the sense of that this balance of autonomous and open that we see happening could actually lead to advanced innovation and be a good context for innovation. So it's this, I think, is one thing. And the other thing I think is that you show is that there is some kind of tension between the direction that we see in lots of European national states, but also in the European Union at the moment, the European Commission, coming in terms of strategic autonomy and sovereignty on the one hand, and global standards on the other hand. And so this will be some kind this will be something that the standard organizations also will feel, this kind of tensions. And it's very interesting to see how they will deal with that. And then I think Your research is extremely timely, and we're very lucky to have you in this InDiCo-Global context, if I may say, because you have a clear view on metrics that we need to assess the situation. In terms of impact on the verticals, like we also hear now with automotive, and this impact on this more horizontal layer. And I think these tensions you've shown very well, and we hope that we can all explore them further in the project. And we also hope that you will want to have another webinar at some point where we talk. So thank you very much. So I want to thank you. I want to thank Uwe. I want to thank Ultam. I want to thank Aletta and Mario for basically being very, very necessary and instrumental and helpful to set up this this entire webinar, without which it wouldn't have been possible. I want to thank all participants, and I think this is a good start of a whole approach of thinking. So thank you very much again, and wishing you a good day. Thank you.